Hello everyone. In this video, I'm going to walk you through everything you need to know about entity relationship diagrams, also called ERDs. Many of you studied in a college specialized different faculties as engineering, law, social sciences, and also registered multiple courses during different semesters. And each time when you enroll for a new courses, the relevant information about you as a student and related course is inserted into school database as a new transaction. In general, a database is an organized collection of data, so you can organize data into tables, rows, columns to make it easier to find corresponding information. So in here, student, faculty, and course information are the main elements of this database. But data modelers need a visual way to understand how these different elements of database interact or relate to each other. So to show this, we need entity relationship diagram. An entity relationship diagram is a visual representation of different entities within a system and how they relate to each other. In other words, ER diagrams help to explain the logical structure of databases. But when do we draw ERDs? While ER models are mostly developed for designing relational databases in terms of visualization and physical database design, there are still other situations when ER diagrams can help us. Here are some typical use cases we can mention about. In software engineering, an ER diagram is often an initial step in collecting requirements for an IT project. It is like a blueprint of a database that allows you to draw database design. It is also an easy-to-use graphical tool for modeling data which helps to describe entities, attributes, and relationships. On the other hand, we can convert ER diagrams into relational tables which allows you to view database quickly. And with the help of it, the database designer gains a better understanding of the information to be contained in the database. So, ER diagrams are created based on three basic concepts: entities, attributes, and relationships. In a typical ER design, you can find symbols such as rectangles to represent entities, ovals to define attributes, and diamond shapes to represent relationships. So let's have a look a little bit detail of these objects. Entities are the basic objects of ERDs. We can assume them as nouns. For example, students, courses, employees, projects, faculty are all main components of ER diagram. When we consider the database, entities are converted to physical tables. When we look at the following diagram, as you see that we have three entities: student and faculty and course. So let's talk about a little bit relationship that exists between these different entities. So relationships describes how these entities will interact each other. When you look at the orange shape that shows the relationship between these entities, we can think also relationships as verbs. For example, student enrolled in a course and the relationship describes the act of enrolling. So in our sample, students study in a faculty and faculty provides us different courses and student enrolled to different kind of courses. So these are all the relationship between these relevant entities. So now we have our relationships in place, and you may notice some characters over there as and one. Relationships are described with the cardinality. So it means that the cardinality defines the possible number of occurrences in one entity which is associated with the number of occurrences in another. So it seems a little bit confusing, but we're going to understand it better with some detailed examples. So three commonly used cardinality relationships are one-to-one, one-to-many, and many-to-many. So let's look at them a little bit detailed. We are going to start with the many-to-one or one-to-many relationship, as we already have some relevant scenarios exist in our presentation. You see that the cardinality between student and faculty is many-to-one. That means a faculty can have many students. However, a student cannot study in different faculties. For example, a student cannot study in both engineering and law at the same time. Therefore, as a student site has many occurrences, it represented with the letter of M. Against this, the faculty is defined as one. Or another sample, a faculty could have many courses. For example, engineering faculty could have mathematics, physics, or chemistry. That is why courses site represented as M, but a specific course like chemistry cannot belong to both engineering and law faculties at the same time. That is why it represented as one side. Or just think a little bit out of the box. A customer can place many orders, but a specific order cannot be placed by many customers. So the rule is, in one entity, there is only one single instance, but associated entity could have more than one instance. So let's look at the many-to-many relationship. Many rows of first table associate with many rows of second table. For example, the relationship between student and course table is many-to-many because a student can take many courses at the same time and a specific course can be assigned to many students. And the last one is one-to-one relationship. Theoretically, when a single instance of an entity is associated with a single instance of another entity, then it is called one-to-one relationship. For example, a person has only one passport and a passport is given to only one person. Or a male can marry to one female, or female can marry to only one male. So the relationship is always one-to-one. And the last green boxes shows the attributes. Attributes are facts or description of entities. For example, student first name, last name, or faculty name, course name are all descriptive characteristics of relevant entities of student, faculty, and course. Remember, each entity in your diagram represents a table within your database, and attributes are descriptions of entities, and they become the columns of these tables on the database. An attribute has a name that describes the property, and the type of that describes what kind of attribute it is, such as varchar for a string or int for an integer. When an ERD is drawn for physical database development, it is important to ensure the use of data types that are supported by the target relational database management system. Additionally, attributes will take place in different functionalities, and we are going to focus on the most two critical ones. Primary key is an attribute or sometimes set of attributes that uniquely identifies every record in a certain table. So for this student table, which is based on student entity, the primary key is going to be a value that makes this student is unlike any other students in our table. There are a few rules we need to consider in order to qualify an attribute as a primary key. So primary key has to be unique, it needs to be never changing, and finally primary key needs to be never null. So let's look at a specific customer like Jim Black in here and determine what data might be uniquely identify him. So, well, you can't rely on the names because two totally different customers could very easily share the same first name and last name. So that leaves us with the customer ID. By design, any sort of ID is typically programmed to increment for each addition to the table. Jim's customer ID will completely identify him as a particular instance in our database, and that value won't be repeated in this table. So let's think about some real examples that we can encounter every day. So have you ever tried to create a username for a website or email account and then later wanted to change it to something else because it was not easy to remember, but then you can't because the website doesn't allow you? The reason behind is probably your username is being used as a primary key in the database of this website. Because the primary keys can never change, they don't let you change it because their system relies on primary key for accurate records. Or how about when you are setting a new account and you try to create a username but get an error message saying that it is already taken? Again, this could be happening because the username is being used as the primary key and primary key cannot be repeated. And the second critical attribute for us is the foreign key. So foreign key, sometimes we call it as reference key, is used to link two tables together. So typically you take the primary key field from one table and insert it into the other table where it becomes a foreign key. So note that foreign key is not needed to be unique. Multiple records can share the same values. If you look at the specific student, it has faculty ID of the E001. This is a foreign key because it references the primary key in the faculty table So now we know exactly which students study in which specific faculty. The same faculty ID is repeated because more than one student can study in the same faculty. And unlike primary key, foreign keys don't have to be unique. They can be repeated in table. And another difference between primary and foreign keys is that there can be multiple foreign keys in one entity. So let's say for each student, we also want to know where they are living. So we would add the address ID to our student table as a foreign key. So in the last slide, we see that we have created an ER diagram based on our business processes. But as a next step, we need to translate this diagram into entity relationship model in order to import our model into target databases such as SQL, Oracle, or MySQL. In here, I'm going to use the diagrams.net. It's a free online software for making flowcharts, process diagrams, org charts, ER, and networks diagrams. So you can simply search diagram.net from your browser and create a new diagram by using your Gmail account. Then I'm going to pick the entity relationship diagram and also create. You can pick any folders you are using, and I'm just going to use the use root folder. It already opened the standard tables that, so if you want, you can already use the standard tables, but I'm going to delete them. So there's a conversion guide that contains steps to how you can translate each object from entity relationship diagram into a relational data model. And this will basically help us. So first of all, I'm going to take each of these entities and make a table. As we have student, faculty, course entities, we will turn them to tables within the same name. Then as a next step, I'm going to define the primary key values and split remaining attributes into relevant tables. For example, as we discussed earlier, student ID is the primary key value that defines each student as a unique record in the system. And first name and last name is the other descriptive characteristics. And additionally, course ID and faculty ID is also the primary key fields for course and the faculty tables. And we are going to also add the faculty name and the course name as the additional attributes to relevant tables. So now we are going to define the relationship, and in relational models that we already know that the relationships are defined with the foreign key columns between the tables. So when we look at the relationship between student and faculty, it shows a faculty can have many students, but a student cannot study in multiple faculty at the same time. So that gives us a one-to-many relationship. As you remember, when we are creating a relationship with one-to-many or many-to-one cardinality, we take the primary key field from the one side, in here it is faculty table, and put it on the many side, the student table, as a foreign key. So similar scenario we have for the relationship between the faculty and courses. As a faculty would have multiple courses, there is one-to-many relationship between them. So similarly, we pick the primary key value from one side, in here it is faculty, and put it into the M side. It means the course table includes faculty ID as a foreign key column. And the last one is student can enroll many courses and a course can be registered for many students. So we have many-to-many relationship in here and the challenge begins. And how we're going to solve these relationships. So that is where the bridge tables comes in. To resolve many-to-many relationship, you can create a bridge table or intermediate table called enrollment. Each row in the enrollment table is unique, representing one student enrolling to one course. The primary key of the enrollment table is a composite key, made up of both columns student ID and the course ID. So if a student has several courses, there are several rows in the enrollment table for that specific student. And if a course is enrolled by several students, there are several rows in the enrollment table for that specific course. By acting as a bridge table between the course and student tables, the enrollment table enables you to solve many-to-many relationship between these two tables. So we are going to create one-to-many relationship between student and enrollment table. And also we're going to create additional many-to-one relationship between enrollment and the course table. As we mentioned in here, we have two primary key and foreign keys and it creates a composite key. And a composite key is a primary key composed of multiple columns used to identify a record uniquely. But you may ask yourself, why not just create an enrollment ID attribute so we don't have to bother about the composite key? Actually, it is possible, so you would certainly use the enrollment ID instead of composite key. And it's actually quite a debate amongst some modelers, but it also depends on the database you're creating, and if there are certain scenarios where a composite primary key makes sense, then you can use it. So now we have converted this ER diagram into a relational data model, and it is ready to be imported by your database. That could be Oracle, SQL, or MySQL. So thank you for listening.